Good evening, sir.
Yeah, good evening. Harit.
Good evening, sir. Sir, you are in mute.
Yeah, good evening. So, in the last class, we finished squares and square roots, right? So, today we'll be starting off with a new chapter, which is, yeah. So, this chapter we're going to be starting now is called LCM and HCF. Okay. It's a very important chapter for your Sainik entrance exam. So, today's chapter is LCM and HCF. Okay, so before we get started, I wanted to tell me what is a factor and what is a multiple. I think I've told you what is a factor before. So what is a factor? A factor of any number. What is a factor?
So that number is again repeated in another table.
No, that is not a factor. That is a multiple. Okay, let's say I give you a number. Let's say 8. What are the factors of this number? What are the factors of 8?
1, 2, 4, 8.
Yes, sir. 1, 2, 4, and 8. Which means any number which divides 8 properly, right? So a factor is any number which divides that number equally. Or when I say instead of equally, I'll say properly. When I mean properly, I mean there should be no remainder left. Okay. That divides that number without leaving a remainder. So if you divide 8 by all of these numbers, you'll get a number which and no remainder left. Okay, so that is called a factor. And I've taught you the method to find out factors for big numbers also. So for example, if you want to find out the factors for 32, what will you do? How will you find the factors of 34, 32?
Prime factorization.
More easier method than that. Yeah, you can find the factors by prime factorization also, but what is the most easiest method? Remember this 1 into 32. Start from 1 and see what gives 32. Okay, so 2 into what? 2 into what will give me 32?
16.
16. Good. So similarly 3. Will 3 give me 32?
No.
No, sir.
Okay, how about 4?
Yes, sir.
4 into
8.
8. Then what about 5?
No,
No.
sir, it does not.
6?
Sir, even it doesn't.
7?
No, sir.
No, sir.
Then 8 onwards is written over here only, right? So we finished. So 1 is a factor, 2 is a factor, 4 is a factor, 8 is a factor, 16 is a factor, 32 is a factor. So the factors of 32 are 1, 2, 4, 8, 16 and 32. Okay. Okay, so now you know what are factors. Now tell me, what are multiples? What is a multiple? Multiple is quite easy actually. So if you multiply any number with any other number, then you can call that number as the multiple of that number. So for example, multiples of 2 is 2, 4, 6, 8, 10, 12, 14 and so on. Okay. Similarly, can you tell me the multiples of 3?
3, 6, 9, 12, 15, 18, etc.
Yes. So these are the multiples of 3. Okay. So this is very important, learning about factors and multiples. Okay. Hello. Am I audible?
Yes, sir.
Okay. So now come to something called as common multiples. So remember we wrote for 2, the multiples of 2 are 2, 4, 6, 8, 10, 12, 16, before that 14, 16, 18 and so on. Similarly for 3, we wrote 3, 6, 9, 12, 15, 18, 21, 24, 27 and so on. Now can you tell me the common multiples of 2 and 3?
12, 18,
12, 18, 24.
6.
Okay, 12, this is common. Then
6.
18.
6,
18.
then 18, right?
24.
Yeah, so even here 24 also comes, so that is also a common multiple and it goes on, right?
30.
So you see 6, 12, 18, 24, all these are common multiples, right? Now, which is the lowest out of all these numbers? The circle numbers, which is the lowest?
6.
6. 6 is the lowest, right? So 6 over here, we are going to call it as the lowest common multiple. Or in short form, we just call it as the LCM. Okay, so lowest common multiple. All these are the common multiples. The lowest of them is 6. So for 2 and 3, the LCM is 6. So the LCM of 2 and 3 is 6. Okay, now can you tell me the LCM of, let's say, 6 and 8? I want you to tell me the LCM of 6 and 8. First write the multiples of 6, then multiples of 8, then tell me the lowest common multiple. So 6 and 8. Yeah, what is the LCM of 6 and 8?
So 24.
Yes. So the LCM of 6 and 8 is 24. Because 6 is 6, 12, 18, 24, 30, 36, and so on. Whereas 8 is 8, 16, 24, 32, 40, 48, and so on. The common multiples in all of these is 24, right? Even after 36, we get 42 and 48. So even 48 is the common multiple. What is the lowest common multiple? That is the LCM is 24. So the LCM of this is equal to 24. But now you know how to find the LCM in this method, where you just write down the multiples and then select the lowest one. But that takes a lot of time, especially if it's a very big number. For example, if I tell you to find the LCM of 144 and 132, then it's going to take a lot of time if you're going to sit and write down all the factors and then choose the lowest one. So instead, what you do is, there's another method. So method number 2, to find the LCM. This we call it as the, it's a division method. Okay. Now in this division method, let's say I want to find the LCM of 32 and 24. Okay. Now what will I do in the division method is, I'm going to write both the numbers 32 and 24, and I'm going to keep dividing them. I'm going to choose a number over here and keep dividing them till I get 1 on both sides. So for example, we know that they both go by the 2 table, right? So 2, what will I get over here if I divide by 2?
16 and 12, sir.
16 and 12. Then again let me divide by 2. Then what will I get?
8 and 6.
8 and 6. Again if I divide by 2?
4 and 3.
4 and
3.
3. Again if I divide by 2?
2 and 3.
Yes, so 2, but 3 is not divisible by 2. 2 is not a factor of 3. So I'm just going to keep 3 as it is. Okay. Then again if I divide by 2?
1 and 3.
1. 2 divided by 2 is 1. Again I cannot divide by 2, so I'm keeping it by 3. Now I need to get 1 on both sides. So what do I divide it by? I'm going to divide it by 3. Okay, so then I'm left with 1 and 1. Now this finishes the process. Okay, so till you get all the numbers as 1, you have to keep dividing them. Okay, so now what I'm left with is these numbers, this column of numbers. Okay, okay, so now what I'm going to do is I'm going to choose all of these numbers and multiply them. So 2 into 2 into 2 into 2 into 2, that is basically 2 5 times, that is 2 to the power 5. 2 to the power 5 means 2 5 times, so 1 2 3 4 5. So instead of writing the whole thing, I just write it as 2 to the power 5 into 3. So what is 2 to the power 5, or 2 into 2 into 2 into 2 into 2?
106.
So this is 36 into, sorry, 30, not 36, 32. 32 into 6. This is equal to how much?
96.
Yes, 96. So the LCM of 32 and 24 is equal to 96. Okay. So this is the method where you do it continuously till you get 1 and 1. Okay. Similarly, I want you to tell me the LCM of 14 and 26. What is the LCM of 14 and 26?
One 182.
182. Harith got the same answer?
Yes, sir, 182.
Okay. So which number did you put over here?
So
Two.
first two.
Okay, 2. Then what will you get over here? 7 and
13.
then next, which number?
7.
Yeah, so these are prime numbers, right?
Yes,
Oh,
sir.
just multiply all the prime numbers. So 2 into 7 into 13, that is equal to how much?
182.
182. So this is the LCM of 14 and 26. Understood LCM?
Yes, sir.
Yeah. So now we'll go to another method for finding out the LCM, but yeah, called the prime factorization method. So method number 3. Just know how to do this method. I think you will find method number 2 itself as the easiest. Okay. So prime factorization. Okay, find the LCM of, let's say, 8 and 18. Okay, so first I'm going to find the prime factorization of both the numbers. I know that 8 is 2 into 2 into 2. Or if you don't know how to do that, just do the prime factorization separately. So 2, 4, again 2, 1. So instead of writing 2 into 2 into 2, I can just write it as 2 to the power 3. That is 2 multiplied 3 times. What about 18? 18 I know is 9 into 2, right? And 9 is 3 into 3. So instead of writing 3 into 3, I write it as 3 square into or into 2, right? So now what I do is, out of each one, I'm going to choose the largest value. So here the largest value is 2 to the power 3. Here 3 square is there, here nothing is there. So the largest one is 3. So the LCM is 2 cube into 3 square. So 2 cube is nothing but 8. 3 square is nothing but 9. So 8 into 9 is how much?
72.
Yes. So the LCM of 8 and 18 is 72. Okay. So similarly, using this method, find out the LCM of, let's say, 90 and 36. Yeah, find out the LCM of 90 and 36. What is the prime factorization of 90 and 36? What is the prime factorization of 90? It is 2 into 3 square into 5, right?
Sir, it's the LCM is 1170.
1170. Okay, Harith, you tell me the answer which you got. What is the prime factorization of 36? Thirty-six is 2 square into 3 square. Correct?
Yes, sir.
Yeah. So, which is the highest one over here? 2 square is the highest, right? This is just 2 to the power 1. Only 2 is there one time. But here 2 is there 2 times. So, 2 square is higher. Here which is higher? Both. So, any one is higher. 3 square. Here which is higher? Here nothing is there. So, 5 is highest. Comparing them. So, multiply all of this. 2 square into 3 square into 5. That is equal to 2 square is how much? 4. 3 square is how much? 9 into 5. What is 9 into 5? 9 into 5.
45.
45 into 4. 180. So the LCM is 180. How did you get 1170? Did you understand this method? So first write the prime factorization. So 2, 3, 5 are all prime numbers, right? Then choose the highest one from each group. Out of the 2's, the highest is 2 square. Here it is 3 square, so any one. Then this is 5. So you multiply all of these, then you get 180. Okay.
Yes, sir.
Okay. Okay, now find out using any of the above methods, find out the LCM of 26 and 22.
286.
Correct. So the LCM is 286. Okay. So this is about yes. Okay, so what about the LCM of prime numbers? What is the LCM of 2 and 3?
6.
Okay, what is the LCM of 2 and 5?
10.
2 and 5 is 10. Okay, what about the LCM of 3 and 7?
21.
21. What about 13 and 11?
143.
143. Again, do you know the shortcut for multiplying numbers by 11?
No, sir.
Okay, so listen. So if you're multiplying any two-digit number, so any two-digit number by 11, for example, let's say 12 into 11 or 13 into 11. What you have to do is, okay, let's take 12 into 11. First, write this digit 1, then add both the digits. 1 plus 2 is how much?
3.
3, write 3. Then write this last digit 132. So 12 into 11 is 132. Similarly, for 13 into 11, write 1, then add both the digits. 3 plus 1 is 4. Then write the last digit 143. So 143 is the multiplication of 11. Similarly, 15 into 11 is how much?
165.
Yes, 165. What about,
Sir, can you explain the method again?
okay, so first, okay, so let's take 13 into 11. First, what you do, step 1, take this digit, okay, the first digit. This is 1, right? So write 1, okay. Step 2 is add both of these digits. That is 3 plus 1 is equal to 4. So write 4 over here, okay. Then take the last digit, the remaining digit, that is 3. Just write 3 over here. So you get 143. So 13 into 11 is 143. Understood?
Yes, sir.
Okay. So similarly, what is 26 into 11?
226.
Not 226. 2. What is 6 plus 2?
8.
So 286. It is 286. Similarly, 34 into 11.
374.
Yes, 374. This is the method now. But what if the number is a little bit bigger? For example, let's say 37 into 11. 37 into 11 is how much? Do it the normal way.
400.
400, yes. So if you do it the normal way, you will get it as 407. Okay, but here how you're going to do is this: write the first digit 3, right? Then add both of these numbers. 3 plus 7 is 10, right? So 3 plus 7 is 10. So write 10 here, but 0 plus carry 1. 1 will be carried over here. Okay. Then write the last digit 7. So now you carried this one. What happened? It became 407. Good. Okay. Now tell me what is 97 into 11.
1060.
Yes, 1000.
1067.
It is 1067. Understood, Varshit?
Yes, sir.
Yes. So you take 9, then you know that 9 plus 6 is, 9 plus 7 is 16. So put a 6 over here, add a 1 over here, then write the last digit, which is 7. So you add 9 and 1, you'll get 10, that is 1067. Okay. So this is how to multiply any 2-digit number, only 2-digit numbers. So from, you know 10, so from 11 to 99, you can multiply it by 11 very easily if you just follow this trick. Okay. Yeah, so where were we? We were at the prime numbers, the LCM of prime numbers. So can you see the pattern over here in the LCM of prime numbers? LCM of 2 and 3 is 6. LCM of 2 and 5 is 10. LCM of 3 and 7 is 21. LCM of 13 and 11 is 143. So these are the LCMs. So can you see any pattern in the LCM? The LCM of prime numbers. LCM of 2 and 3 is 6. What else of 2 and 3 is 6? 2 multiplied by 3 is 6, right?
Yes, sir.
Similarly, 2 multiplied by 5 is 10. 3 multiplied by 7 is 21. Then 13 multiplied by 11 is 143. So the rule is, so take down this rule, that LCM of prime numbers is equal to their product or their product. So you know that 17 is a prime number. You know that 13 is a prime number. Instead of sitting and finding out the LCM, you know that even if you try to find it out, you know that this is a prime number, nothing will divide. So you have to do by 17 itself. You'll get, you'll get 1, you'll get 13, then again do 13, again look at 1 and 1. So anyway, you have to multiply 17 and 13. So the LCM of prime numbers is their product. So you just do 17 multiplied by 13. How much is 17 multiplied by 13?
151.
151. Are you sure? It's not 151.
191.
It's greater than 200. Do it. 17 multiplied by 13. 7, this is 2. 5, then 7.
361.
12. Not 361. We're left with 2, 1. 1 into 1 is 1 plus 1 is 2. So it is 221. Okay. So this is about LCM. Now we'll go to HCF. HCF. The first, factors, back to factors. Okay, first now list the factors of 3, 6 and 12. List the factors of 3, 6 and 12. What are the factors of 3?
One and 3.
Yes, 1 and 3. What about the factors of 6?
1, 2, 3, 6.
1, 2, 3, 6. Okay, Harith, what are the factors of 12?
1, 2, 3, 4, 6. I mean, 1, 2, 3, 4, 6 plus.
4, 6, 12. Okay, now which are the common factors?
One, two,
2 is 2 common.
one and 3.
Yes. So 1 is common for all and 3 is common for all. Now which is the highest common factor?
3.
3. So HCF is nothing but the highest common factor. In this, the highest common factor is 3. So the HCF of 3, 6 and 12 is 3. Okay, what about only 6 and 12? What is the highest common factor of only 6 and 12? Remove 3.
3.
No.
6.
Yeah, the other common factors for 6, only 6 and 12 are 6, right? So the HCF of 6 and 12 is 6. Okay. So I think you understood what is the meaning of HCF. Now, how to find the HCF? Okay, let's look at method number. So this is first method. I will find the HCF. Okay, first tell me, just fill in this blank. The lowest common factor for any numbers is dash.
1.
Yes. So whichever numbers you take, the lowest common factors will always be 1. Why?
Sir, because all the numbers come in one table.
Yes, because 1 is the factor for all numbers. Okay. So now let's look at method number 2. Method number 2 is similar to the LCM, but we have a few slight changes. Okay. So let's find the HCF of 8, 12, and 36. Okay. So I'm going to write it like before 8, 12, and 36. And similarly, I'm going to divide it by the common number. Which is the common divisor for these?
2.
Okay, 2. So what am I left with? Here,
4, 6, and 18.
4, 6, and 18. Next, what is the common divisor?
2.
2. Then what is left?
2, 3, and 9.
2, 3, and 9. Now, is there a common divisor for all three numbers?
No, sir.
There is nothing common, right? So in HCF, always remember, very important, in HCF, when nothing is common, you have to stop there only. So now you have to stop because nothing is common. If it is common, all three, some other number is common for all of them to divide it, then you can continue. But there's no common number left to divide all three numbers. So you stop your division over here itself. Okay. So now the answer is this. So 2 into 2 is 4. And this is the HCF of 8, 12, and 36. Okay. Now, you guys tell me the HCF of 144 and let's say 24. One 44 and 24.
$24.
24, right? So 2, what are you going to get over here?
$72 and
72.
12.
Then
36 and 6
then
by 6.
hmm,
So we
what's
can do it
yeah,
by 6.
yeah, direct if you want to do it by 6. But since I'm using prime numbers only over here, I'll go by 3 and 2 and then do it by 3. So this is 18 and 3. Then I do it by 3, 6, and 1. Now nothing else is common over here. So multiplying all of these, I'm going to get 24. Okay, good. Now tell me the HCF of 9, see. 9 and 6.
Three.
Yes. HCF of 9 and 6 is 3. What is the LCM?
18.
18. Now take down a very important formula. Okay, what is the multiplication of this 9 and 6?
54.
54, right? What is the multiplication of this? 18 into 3, how much is that equal to?
54.
It is 54. So your formula is, this is number 1. Let's say this is number 1 and this is number 2. Number 1 into multiplied by number 2 is equal to the HCF of those numbers multiplied by the LCM of those numbers. Okay. So take down this formula. It's a very useful formula. Okay, shall we go on to the next problem? Okay. Now find the HCF and LCM of 8 and 18. HCF and LCM.
Sir, HCF is 2 and LCM is 72.
HCF is 2 and LCM is 72. So instead of finding out the LCM in that normal way, if you know that the HCF is 2, what you can do is you apply the formula, because you know that 8 multiplied by 18 is equal to HCF into LCM. So you know HCF is 2. So let's say you found out the HCF is 2. Okay, you're left with LCM. Now what is LCM? In this formula, according to this, what is LCM equal to? What will happen to this 2? Can I take it to this side? If I take it to this side, what will happen to this 2? I can write it as 8 into 18 divided by 2, right? Have you learned this?
Yes, sir.
Yes. So now what I can do, I can cancel it out, right? So 2 1s are and 2 9s are. So LCM is equal to 8 into 9. That is equal to 72. So instead of finding it out, I can just use the formula. That is where it comes in handy. But the most of the time when they ask you to use this formula is they will give you one number. For example, they'll give you 8. They'll tell you that the HCF is equal to LCM is equal to 72, and they will ask you to find the other number. They'll ask you which is the other number. Then what will you do? Then you have to use this formula, which is 8 into 18 is equal to HCF into LCM, but you don't know this is 18. You only have one number. So the other number you can call it as number 2, or you can call it as X. Okay. So then now you have to find the value of X. Hello, am I audible? Hello, am I audible?
Yes, sir.
Yeah. So now what you have to do is, you know that 8 into the other number, let's say it as X, is equal to, you have these 2 into 72. Now what do? You have to find X. So X is equal to 2 into 72. This 8 will go over here. So divided by 8. Now you know 8 ones are 72 goes in 8 tables as 9, right? So 2 into 9, X is equal to 18. Then you choose it in the correct option. Okay. So this is regarding HCF and LCM. Okay. So in the next maths class, we will solve some problems regarding HCF and LCM. So we'll wind up for today's class. Thank you.
Thank you, sir.
Thank you, sir. Bye, sir.
Bye.
Bye, sir.
Bye.